Hello students, welcome you all on behalf of Resonance, myself Srinivas Naidu, SRN sir. आज 27th जुलाई शिफ्ट 2 मेमोरी बेस्ड पेपर देख रहे हैं. इसमें कौन सा क्वेश्चन आया है? फर्स्ट क्वेश्चन, इन न्यूट्रल मीडियम KMnO4 ऑक्सीडाइजेस थायोसल्फेट 2. इन न्यूट्रल मीडियम KMnO4 ऑक्सीडाइजेस थायोसल्फेट to sulfate ion. It is direct simple question from D block. So, answer is sulfate ion, fourth option. Next, second question, how many among the following are non-planar? This is from chemical bonding related. So, in the given species PCl3 trigonal, it is pyramidal structure PCl3 with one lone pair and it is non-planar, and aluminum hydroxide, it is AlOH4 minus, it is also tetrahedral shape, it is also non-planar, and BF3 trigonal planar, it is having trigonal planar shape, NO3 minus, it is also having trigonal planar shape, and SO3, it is also having trigonal planar shape, and hydrogen peroxide, it is open book structure and it is also planar. So, how many are planar? It is 1, 2, 3, 4 are planar structures. So, इसमें how many are planar? SO3, BF3 and this one NO3 minus, and it is H2O2 is it is open book structure, it is non-planar, it is non-planar. Next one, the group element, the group 1 element A having highest hydration enthalpy has similar properties of group 2 element, then element B is. इसमें group 1 element with highest hydration enthalpy, that is lithium ion, and lithium ion is having diagonal relationship with magnesium ion of group 2. So, these two are having similar properties. So, answer is magnesium. Next, boron is unable to form BF63 minus, and reason boron has small size. इसमें boron unable to form BF63 minus, yes, it is correct. The reason given is also correct, but it is not the correct explanation. Why? Because in BF63 minus, boron, why it cannot form BF63 minus? Boron is not having vacant d orbitals, I mean d orbitals is not there, only p orbitals. So, it cannot expand its octet, that is why it cannot able to form BF63 minus, right. This is the reason, but the given reason is boron has small size. So, boron has small size, it is correct, but it is not the correct explanation. Next question, correct order of ionization energy of the following element with outermost electronic configuration. So, with 3s to outermost electronic configuration, this is for beryllium, magnesium, calcium, strontium, barium, radium. In the second group, the outer configuration is NS2, and for beryllium it is 2s2, and for magnesium it is 3s2. This is for magnesium, right. Next, this is for third period element, that is if you take the third period elements, magnesium, next aluminum, aluminum is having 3s2, 3p1, silicon 3s2, 3p2, and phosphorus 3s2, 3p3. So, this is for phosphorus, and 3s2, 3p1, this is for aluminum, and 3s2, 3p4, 3s2, 3p4 is for sulfur, and for chlorine it is 3s2, 3p5. And it is it is ionization energy. Regarding ionization energy, from left to right, ionization energy usually increases, but when you compare magnesium and aluminum, here magnesium and aluminum, if you compare, magnesium is having completely filled configuration, that is 3s2, aluminum has incompletely filled configuration. So, to remove the electron, more energy is required for magnesium when compared to aluminum. And now, when you compare this phosphorus and sulfur, it is having half filled configuration and sulfur has incompletely filled configuration. So, to remove the electron from phosphorus, it requires more energy than sulfur. Okay. So, this is for sulfur and this is for aluminum, phosphorus and magnesium. Now, the correct order of ionization energies is C is less than, that means it is C, it is D, C less than, A less than, D less than B. So, this is the order for ionization enthalpies. Next, in how many of the following ores iron is present? Here the given ores are hematite, siderite, cassiterite, kaolinite, sphalerite. In these, if you observe the formula, hematite is Fe2O3, siderite is FeCO3, cassiterite SnO2 and kaolinite aluminum ore and sphalerite, this is zinc sulphide. So, the correct answer is only 2. Next, this is from surface chemistry. Assertion: dissolved substance of colloidal solution can be separated by using parchment paper, and reason: particles of true solution cannot pass through the parchment paper, while particles of colloidal solution pass through the parchment paper. And here colloidal solution particles cannot pass through the parchment paper. So, the dissolved substance in the colloidal solution can be separated, that means dispersed phase can be separated by using this parchment paper. Whereas, if you observe the particles of true solution cannot pass through parchment paper, and while the particles of colloidal solution pass through parchment paper. This is the reason given, which is wrong. The true solution particles can pass through the parchment paper, whereas colloidal solution particles cannot pass through the parchment paper. So, assertion is correct, but reason is wrong. Next, metal in complex have low oxidation state when ligands are organometallic compounds. इसमें when metal has low oxidation state, then it is having more electron density. If it is having more electron density, then the metal can able to donate the d orbital electrons to the ligand, and the ligand that is present can accept that electrons. That is why if the ligand is a good pi acceptor, then it can able to accept that electrons. That is why here the answer is good pi acceptor. So, metal in complex have low oxidation state, तब ligands कैसे होनी चाहिए, good pi acceptor है तो तब metal का oxidation state low oxidation state हो जाएगा. क्यों low oxidation state हो रहा है? क्योंकि जब ये लो ऑक्सीडेशन स्टेट में तभी हो जाएगा जब इसके पास इलेक्ट्रॉन डेंसिटी होता है मेटल के पास. जब इलेक्ट्रॉन डेंसिटी होगा ये इजीली डोनेट कर सकता है, तब लिगैंड इजीली एक्सेप्ट भी कर सकता है. नेक्स्ट, फेरिक सॉल्यूशन रिएक्शन विथ पोटेशियम ferrocyanide gives Prussian blue color due to the formation of which complex? Prussian blue colored complex formula Fe4FeCN6 thrice. It is qualitative analysis के related question. When I am ferric ions identification में ferric ions can be identified by adding potassium ferrocyanide. then a blue colored precipitate is obtained, that is Prussian blue. Its formula is Fe4 FeCN6 thrice. Next question, this is from ionic equilibrium. Identify the correct titration graph for titration of ammonium hydroxide versus HCl. इसमें HCl को हम ब्यूरेट में ले रहे हैं और कॉनिकल फ्लास्क में NH4OH लिया है. इसको हम ड्रॉप बाय ड्रॉप HCl ऐड कर रहे हैं और HCl ऐड करके ये रिजल्टेंट सॉल्यूशन की pH हम कैलकुलेट करके वो रिजल्टेंट pH एंड वॉल्यूम ऑफ द एसिड दोनों के बीच में हम ग्राफ ड्रा कर रहे हैं. जब HCl नहीं ऐड किया तब इसमें केवल अमोनियम हाइड्रोक्साइड है, ये वीक बेस है. सो इसके लिए pH विल बी ग्रेटर देन 7 होगा. सो pH यहाँ ग्राफ्स में pH हायर वैल्यू शो करेगा ग्रेटर देन 7. नेक्स्ट, ये pH हायर वैल्यू मीन्स इन दोनों में ये इस तरह के हायर वैल्यू शो कर रहा है और इसमें लोअर वैल्यू ही शो कर रहा है. सो 3 and 4 नहीं हो सकता. और 1 and 2 में फिर इसमें HCl ऐड करने के बाद क्या होगा, अमोनियम हाइड्रोक्साइड HCl से कंबाइन होके अमोनियम क्लोराइड प्लस H2O बनेगा. इट इज द साल्ट ऑफ वीक बेस स्ट्रॉन्ग एसिड एंड अगेन इट इज वीक बेस. इसमें वीक बेस है और HCl ऐड करने के बाद जो साल्ट बनेगा वो साल्ट ऑफ वीक स्ट्रॉन्ग एसिड वीक बेस है. सो ये बेसिक बफर सॉल्यूशन बन गया. सो बेसिक बफर सॉल्यूशन बनने के बाद pH क्या होगा, ये रेसिस्ट हो जाएगी, दैट मीन्स इंक्रीज या डिक्रीज नहीं होगा. तो इसलिए यहाँ आपको pH चेंज ज़्यादा तुरंत नहीं आएगा, ये ऑलमोस्ट pH स्लाइटली डिक्रीज हो जाएगी और ये ऑलमोस्ट कांस्टेंट हो जाएगी, क्योंकि ये कर्व क्या शो कर रहा है, ये कांस्टेंट कर्व. इट इज शोइंग द फॉर्मेशन ऑफ बफर सॉल्यूशन एंड until the ammonia which is taken in the beaker, it is completely consumed, the pH is gradually decreasing and after the end point the HCl when added the pH suddenly decreases. So, the curve obtained will be like this. This is the pH titration curve for weak base and strong acid. और ये कर्व क्या शो कर रहा है, इट इज द ग्राफ फॉर स्ट्रॉन्ग बेस वर्सेस स्ट्रॉन्ग एसिड. ये स्ट्रॉन्ग बेस वर्सेस स्ट्रॉन्ग एसिड के बीच में कर्व इस तरह बनेगा और ये कर्व ये वीक एसिड वर्सेस स्ट्रॉन्ग बेस के बीच में कर्व है और ये कर्व वीक एसिड वर्सेस वीक बेस के कर्व हो जाता है. सो इसमें अपने क्वेश्चन का कर्व कौन होगा, ये स्ट्रॉन्ग एसिड वर्सेस वीक बेस कर्व. सो आंसर इज 1. Now, for real gas, value of compressibility factor is 2 at 25 degree Celsius and 99 atm pressure. Then value of van der Waals constant B is, ये बहुत दिन के बाद ये क्वेश्चन आ गया रियल गैसेस से. अब इसमें van der Waals इक्वेशन फॉर 1 मोल ऑफ गैस हम ले रहे हैं, इट इज P प्लस ये बाय Vm स्क्वायर इंटू Vm माइनस बी इक्वल टू RT और इसमें Vm इज नथिंग बट वॉल्यूम ऑफ 1 मोल ऑफ गैस. एट हाई प्रेशर क्या हो जाएगी, Vm विल बी लो, सो B cannot be neglected, that is excluded volume cannot be neglected in comparison to Vm. अब ये by Vm square can be neglected क्योंकि Vm value is low and ये by Vm square can be neglected because of low attraction forces and इसकी वजह से van der Waals इक्वेशन बनेगा ये P into Vm minus B equal to RT और इसको एक्सपैंड करेंगे तो PV by RT इक्वल टू PV by RT plus 1. ये PVM by RT is nothing but Z. Z equal to PB plus RT by 1. Now 2 equal to Z, compressibility factor Z है, compressibility factor Z, it is given as 2 and pressure is also given 99 atm. B calculate करना है अपन को, R value is given as 0.083 and temperature is also given, that is 25 degrees Celsius, that means 298 Kelvin. Now B equal to, if you calculate, you will get 0.25. Now it is written as 25 into 10 power minus 2. So B value can be 25. Here it is 25. Now this is the question from atomic structure, that is arrange the following according to decreasing order of energy. इसमें आप देख सकते हैं n value equal to 3, L0, M0, S equal to minus of, n equal to 3, L equal to 1, M equal to minus 1, S equal to plus of. ये क्वांटम नंबर्स कौन से ऑर्बिटल इलेक्ट्रॉन की शो कर रहा है, 3s ऑर्बिटल इलेक्ट्रॉन, और ये क्वांटम नंबर्स आर रिप्रेजेंटिंग, it is n equal to 3, L equal to 1, this is representing 3p orbital electron, and n equal to 3, L equal to 2, this is representing 3d orbital electron quantum numbers, and n equal to 4, L equal to 0, these representing 4s orbital electron. अब इसमें n plus L वैल्यू जिसका कम है उसका एनर्जी कम होगा, और इसमें 3 plus 0 इक्वल टू 3 एंड 3p ऑर्बिटल के लिए 3 plus 1 दिस इज इक्वल टू 4 एंड 3d ऑर्बिटल के लिए 3 plus 2 दैट इज 5 एंड 4s ऑर्बिटल के लिए 4 plus 0 दैट इज 4. इसमें ये सबसे कम एनर्जी किसका होगा, 3s ऑर्बिटल के लिए. सो इट इज सबसे लोअर एनर्जी वाले. नेक्स्ट इन दोनों में दैट इज 3p एंड 4s में किसका एनर्जी कम है, एज पर अबॉव्स प्रिंसिपल जिसका n वैल्यू कम है उसका एनर्जी भी लो होगा. इफ n plus L value is same, then the orbital with lower n value is having lower energy. So 3p orbital has lower energy than 4s. So 3p means it is B, and next it is D, and higher energy is for 3d. 3d means it is C. So this is the increasing order of energy, and हमको यहाँ डिक्रीजिंग ऑर्डर ऑफ एनर्जी बताना है, C ग्रेटर देन, D ग्रेटर देन, B ग्रेटर देन, ये होगा. नेक्स्ट क्वेश्चन, इन 100 grams of water ये solute is added and vapor pressure of solution is half of the pure solvent. The vapor pressure of pure water is given 23.76 mm of Hg. Find the number of moles of solute added. From relative lowering of vapor pressure relation, P naught minus Ps by Ps equal to number of moles of solute by number of moles of solvent. अब इसमें P naught minus Ps value given as half of the vapor pressure of pure solvent, so P naught by 2, and Ps is again written as P naught by 2, and number of moles of solute by number of moles of solvent is 100 into 18. Now number of moles of solute, if you calculate, it will be 5.55, and if you round off, it will be equal to 6. Next one, 100 ml of 0.1 normal H2SO4 is mixed in 50 ml of 0.1 molar NaOH solution. The normality of resulting solution is. It is also very simple question. इसमें H2SO4 और NaOH रिएक्ट हो गया तो Na2SO4 और H2O बनेगा. इसमें मिलीमोल्स ऑफ H2SO4 इज 10 एंड मिलीमोल्स ऑफ NaOH इज 5. ये मिलीमोल्स हम कैसे कैलकुलेट कर रहे हैं, मोलैरिटी इंटू वॉल्यूम, ये 100 इंटू 0.1 ये 50 इंटू 0.1, सो ये हो गया 5, ये हो गया 10. नाउ मिलीमोल्स आफ्टर द रिएक्शन H2SO, इसमें NaOH का लिमिटिंग रिएजेंट है NaOH, और इससे हम ये कैलकुलेट कर रहे हैं H2SO4 लेफ्ट, H2SO4 मिलीमोल्स लेफ्ट इज 7.5, और मोलैरिटी ऑफ H2SO4 विल बी 7.5 बाय टोटल वॉल्यूम, ये 100, ये 50, 150 ml. नाउ नॉर्मलिटी ऑफ द सॉल्यूशन इज ट्वाइस द मोलैरिटी for H2SO4 because 2 is the valency factor for H2SO4. Now it will be equal to 1 into 10 power minus 1. Now it is 1 because we have to express this in the form of some x into 10 power minus 1. So वो x value क्या होगा, 1 होगा. Okay. Okay बच्चों, that's it in this paper. We will meet you in next paper. Thank you.